Hey everybody, hi, it's Miss Erickson. Sorry I'm not here today. I am sick, and I just want to remind you all to be wearing your mask if you're sick, or if you were sick recently, or if you're coughing or sneezing actively, wear your mask, wash your hands, and take a COVID test, because it could be COVID. It is for me, sad face, I know, womp womp. I'm feeling okay. But what I thought was a regular cold turned out to be COVID. So make sure you take COVID tests. We have them for free at the office. So if you're sick and you think maybe it's COVID, it could be COVID, go check. Just want to remind you all. So I'm not going to be here until I'm COVID clear, because that's what we're doing. We're being responsible. So wear your mask, wash your hands, and take COVID tests. Mr. Bro is here today. He teaches this exact same class, so please feel free to ask him questions at any time. He's the best and very knowledgeable on this topic. He also teaches AP Environmental Science, and today we're talking about climate, so he knows a lot about this. Also, he did, I think, get his master's in this topic, so he's got a lot of knowledge on this, so use him as a resource. He is busy during this time. He has lessons to plan and papers to grade, just like I do. And he's taking his time to sub our class and answer questions and keep you guys safe, keep an eye on you while I'm out. So I'm going to be doing like a pre-recorded lecture. There will be time in it for you to talk to your neighbor about questions I'm posing. So please do talk to your neighbor and think about the questions that I'm bringing up, because that's how your knowledge grows. You don't just sit there and absorb. Sit there and synthesize. Make your own ideas ahead of time and feel amazing when your answers are confirmed, or be like, oh my goodness, I have a deeper understanding now that I thought about it, and then my misconceptions were corrected. Okay, so you should have, before we dive in, you should have 3 colors. You should have green, red, and yellow colors. You should grab them from the handout table if you don't have your own green, red, and yellow colors. So go grab those now. I'm going to give you just a couple moments. Go grab them. I'm actually going to grab them myself. So green, red, and yellow. Go! Okay, coming back. All right, green, red, and yellow. We're going to need these today, so please have them ready to rock. All right. So you should have updated your table of contents. What we did last time with the beans was the carbon flow observation. Today we're going to be doing Keeling curve, old versus new carbon. One of my favorite things to talk about. I'm actually heartbroken I'm not here today. Greenhouse effect notes. And then we're going to be talking about climate feedback loops. And you told your neighbor what the sad leafless tree does for energy during winter. What did you tell them? Tell them one more time. I'll give you a moment. I know you're talking right now. Good job. All right. So, you told your neighbor what the sad leafless tree does for energy during winter. And you might have said the same thing it does during summer, all right? The tree does the same thing all year round for energy. Cellular respiration. Remember, photosynthesis makes glucose, which is a type of stored energy from the sun. However, glucose itself is not able to be used for energy directly. Just like we do, plants do cellular respiration. They have chloroplasts and mitochondria, and the mitochondria turns the energy that was stored in glucose into ATP energy. So all year round, the tree is doing cellular respiration. So all that energy that it's stored in its plant body during spring and summer is being used by the tree during winter and when it's leafless before its leaves grow back in the spring. So it's doing cellular respiration all along, and it's always releasing carbon dioxide and water as waste products all year round. It's just sometimes of the year it's doing photosynthesis as well and taking in that carbon dioxide at the same time. So, Mr. Bro, please go check the light tubes in the light box. It's the one on the right. Remember, folks, I showed you those tubes last time. They both had bromothymol blue solution in them. When bromothymol blue solution has little to no carbon dioxide in it, it's blue. And when it has increasing amounts of carbon dioxide, it turns green to yellow. All right, so what does it look like? So it should have looked like this. The Alodia kept in the light for 2 days looks like this. All right, still blue. And that's because in the light, it's doing respiration and photosynthesis. It has very little carbon dioxide in the water because photosynthesis is absorbing the carbon dioxide. And the Alodia kept in the dark for 2 days, it has high carbon dioxide in the water because it's only doing respiration. Remember, plants do respiration all the time. Just sometimes they're doing photosynthesis as well when there's light. And as they do photosynthesis, they reabsorb that carbon dioxide that they emitted. When it's dark, they're only doing respiration. So we have high carbon dioxide in the water due to respiration, waste products that we all emit, carbon dioxide in water, but they're not reabsorbed because it's not doing photosynthesis. Isn't that cool? You love it. Mr. Bro, if you could put it back in the light box, that would be excellent. And after second period, if you could put the Alodia that was in the dark back in the light box, but without the foil. I don't want to kill the Alodia. Thank you. All right, so we're going to be tracking carbon dioxide in the atmosphere in our activity today. And the data that we're looking at is from the Mauna Loa Observatory. It's right here. Maybe some of you have hiked up to it before. If you've been to Hawaii, I haven't. Someday. But the Mauna Loa Observatory is a very special place in that it is a uniquely situated place where there's no vegetation, there's no plants. It's really high up, so it's away from what's called point sources of like pollution and carbon dioxide. So it's far away from cars, it's far away from power plants, it's far away from cement making plants, for example, places that would emit a lot of carbon dioxide. It's so high up, it's away from any pollutants that could be affecting the carbon dioxide tracking ability. So this video, it's super short, I think it's 4.5 minutes, explains why the observatory is in Mauna Loa and what they do. It's really, really cool. So just take a moment to watch.